Hi everybody. Welcome to the first of two sections that we're going to spend in Module 4. Module 4 is on mixed designs, which are designs that have both a within subjects independent variable and a between subjects independent variable. So the one we're doing today is a repeated measures Anova, just like we did before, only now we're going to add a between subjects factor. So if you remember in our within subjects tests, which are both the paired t-test or repeated measures Anova, we were looking for whether there was a difference in a numeric dependent variable across time or across conditions. So we had the same set of individuals, and we were looking at two or more measures on each individual and looking to see if there was a difference in them. So now we're going to add the fact that these individuals are divided into two or more groups. Okay, and this grouping variable is our between subjects factor. All right, so in this test that we're going to run, our dependent variable is the repeated numeric observations that occur, and then we have two independent variables. One is the within subjects factor, which is the measure over time or over conditions, and then the other one is our grouping variable, the between subjects factor. So I realize that may sound abstract, so let's talk about an example. This is one that I actually worked on with somebody. We had a professor at Queens from the music therapy department who was working on a research project, and I helped her with the statistics of it. And she was doing a study where she had a group of people who had experienced a death of someone close to them, and they were divided into two support groups. Some of them did talk therapy, and the other one did a music therapy design. They participated in a grief chorus, I believe is what it was called, a grief choir. And over the course of a year, she gave them periodically a scale. There was a numeric scale that somebody had developed to measure, if such a thing can be measured, grief. And then what she wanted to know was, overall, is there a difference in outcomes for the two groups, music therapy and talk therapy? She hoped to show that music therapy was beneficial. So there are three questions that we're looking at for any repeated measures Anova with the between subjects factor, which is a mouthful. The first one is there a main effect of the within subjects factor? So in the case of the support group, is there a difference over time of how people experience grief? Does it increase? Does it decrease? Does it increase and then decrease? Whatever that trajectory looks like. The second question is, and all these are hypotheses essentially, is there a difference in the means by group? So for this example, we'd be looking at, is there a difference overall between the music therapy group and the talk therapy group? And then the third question is there an interaction between the groups? Meaning, for example, maybe talk therapy had a sharp increase at the beginning, but then they leveled off, whereas the music therapy group had a steady improvement. That's just an example. So did they behave differently over time? A profile plot can be very useful, and we're going to see one in just a minute. we're going to put our within subjects variable on the horizontal axis, and this is always what you're going to want to do here. Put the within subjects variable on the horizontal axis, and then the between subjects variable as separate lines. So the example we're going to run, because I don't have the data on that Grief Choir example, we're going to look at the attention span data set, which is familiar to us. We're going to run a repeated measures ANOVA on the amount of time spent on the 4 activities. Those were watching TV, exercising, studying, and doing chores. And we're going to use gender as a factor. So now let's look at some of the nitty-gritty of the test. So the assumptions of this test are still the same as just with the repeated measures ANOVA. The most important assumption is sphericity. And we're going to test just like we did before using Mauchly's test. So to run the test in ANOVA, and I've got the attention span data set up now, we're going to go to Analyze, General Linear Model, Repeated Measures. And that's just like we did before when we were doing the repeated measures ANOVA. And we need to define our factor. So our within subjects factor name, I'm going to call it activity. In my notes, I think I called it time spent, but I think activity is a more descriptive term. And there are 4 levels. So we're going to click Add, and then we have to define that. And we're going to put our 4 measures over here. Number of hours per week spent watching TV. Number of hours per week spent exercising. Number of hours spent studying. And number of hours spent on household chores. And by the way, it can be very useful to write down 1, 2, 3, and 4, what those 4 measures are. Because as far as I know, in SPSS, there's not a way to add labels to 1, 2, 3, and 4. When they show up in the profile plot and in the post-hoc tests, they just show up as 1, 2, 3, and 4. So it can be helpful to write down what those represent. So far, this is all we've done. Now in today's lesson, we're going to add gender as a between subjects factor. So this is the new part. And just like we did before, under Options, we're going to click Descriptive Statistics and Estimates of Effect Size. And we're going to do a profile plot. So under Plots, we're going to put activity on the horizontal axis, because that's our within subjects variable. And we're going to put gender as separate lines, because that's our between subjects variable. So we'll click Add, and then we'll click Continue, and OK. And it's going to give us a bunch of output eventually. While it's doing that, let me mention that when you run the main test, you're going to use the sphericity assumed option if sphericity is not violated. Otherwise, you're going to use Greenhouse-Geiser. And if you remember on Mauchly's test, reject H0 on Mauchly's test means the sphericity is violated. All right, so let's look at our output, and I've copied all of this over here so that we can just look straight at it and I can draw on it. The effect size is still partial eta squared, and you'll just need to state those. There's nothing really further you have to do for that. And then when we run the post hoc tests, we'll get to that in a minute, but it's the same thing we did before. Under EM means, it's compare means, and we're going to use Bonferroni if sphericity is violated, otherwise the least squares difference none. If you have a between subjects factor that is significant, you're going to use Tukey, just like we've used before. Okay, but keep in mind, you don't run post hoc tests on any within subjects or between subjects factor if it's not significant, or if there are only two groups or conditions. Okay, because the post hoc tests give us all the pairwise comparisons. So let's look at the SPSS output for the attention span analysis we just ran. This is what we have over here, and I just copied and pasted it over here so we can draw on it and make it a little bigger. So this is where I wrote down what our four conditions are, so we'll have it to refer back to. The first thing we see in the output is the descriptive statistics, so that can be useful. That you may want to state some of those in your write-up. Next thing is this table called Multivariate Tests, and it is not useful. This is, again, Multivariate Tests, not useful. This is a different kind of test you can run, similar to the repeated measures Anova, but it's not as powerful, so we're not going to use it. This is Mauchly's test. This is where you're going to test your assumption of sphericity. So we've got here's our test statistic, but the important thing here is our p-value. So this tells us p is less than 0.001. So the sphericity assumption has been violated. All right. So this tells us that if we need to run a post hoc test, we're going to use Bonferroni, and on the main test, we're going to use Greenhouse-Geiser. All right. Test of within subjects effects. This is our main test right here. So this is where we test our within subjects variable and the interaction. So we've got hours spent. This is our activity variable. And sphericity was violated, so we're not using this option. We're using Greenhouse-Geiser. Either way, we've got, this is our test statistic. This is our p-value. And this is our partial eta squared. So our p is less than 0.001. And you're going to use this other information too. So, which activity the adolescent participated in is significant. This is a main effect. So there's a main effect of this variable. Down here is our interaction. And again, we need to use Greenhouse-Geiser. This is our F value, so our test statistic. This is our P value. And this is our partial eta squared. So here we've got P equals 0.087. So the interaction is not significant. So we don't have a significant interaction. Now, before we can test the between subjects effect, remember that we're not using these within subjects contrasts for anything. This is just if you want to do some kind of, if you have time series data and you want to check whether it's linear, quadratic, or whatever. So we're not using that for anything. And our test of between subjects effects, this is where we test for a main effect of our between subjects variable. So we're looking at gender. Our F value is 0.005, which is tiny. Our P value is huge. And our partial eta squared is so small that it's showing as 0.000. So our P value is 0.945. So gender is not significant. And by the way, if you see a partial eta squared like that, you'd still write that as P less than 0.001 because it's not actually 0. It's just 0 to 3 decimal places. On the profile plot, I think you get a good visual of what we've seen. There is a difference across our 4 treatments. Remember, this one was TV. This one was exercise. This was studying. And this was doing chores. So it looks like they're doing the most amount of time on TV, followed by exercise, followed by studying, followed by chores. And this is true for the most part, regardless of whether the child is a male or female. There's a little bit of a non-parallel up here. So it looks like there might be a little bit of an interaction going on here, but remember that wasn't significant. So, so for the most part, we don't have a difference between the 2 lines, which is why there wasn't a significant difference between males and females. That's our main effect of gender. These lines are, for the most part, parallel, which is why there wasn't a significant interaction. But we can see that there is definitely a difference across these activities. So we ran our post-hoc tests. And I'm going to walk you through that in SPSS here. So analyze, we're going back to repeated measures. And you just have to click past that. You don't have to redefine that. So for EM means, we want to see activity. So we're moving EM means over here. And we're going to compare main effects. And because sphericity was violated, we're going to use Bonferroni. Now, if we wanted to run a post hoc test on gender, which we're not going to do because there's just 2 values of gender, but if we had more than 2 and we had this was a significant effect, we would click on post hoc. This is where you do the post hoc tests for the between subjects variable. So you'd move gender over here and you'd pick Tukey, just like we did before. But we're going to cancel out of that because we're not going to do that. So we have our output here. And here are our pairwise comparisons. This is our post hoc for the within subjects variable for the activity, which activity they did. And we can see that we have a significant difference here, here, and here. And then those 3 are just these repeated. So we have a significant difference between, let's see, one was TV. So between TV and chores, between exercise and chores, and between exercise and studying. So those are our 3 significant differences. So now for our write-up, not much different than what we've seen before. We start with a sentence describing what test we ran. We did repeated measures Anova, and we said that these were our within subjects. And so that's why we said repeated measures Anova was on this variable. And then gender was our between subjects factor. We talked about our assumption of sphericity, and that because that was violated, that's why we're using Greenhouse-Geiser. We talked about our results, stating the test statistic, the p-value, and the partial eta squared on the 2 main effects. So we said that activity was significant, gender was not. Gender is really not with a p-value of 0.945. And we also talked about our interaction. So you've got to talk about all 3 of these, the 2 main effects as well as the interaction. And then, because we had to do a post hoc test on activity, we talk about the results of those. Clicked on the wrong thing there, sorry. You might add that post hoc tests were not conducted on gender since it was not significant. And also because there are only 2 levels. Either one of those would be a legitimate reason for not running post hoc tests on that. All right, so that's it for this lesson. I will see you in class.